In question 1, we're given the probability distribution of the random variable x, and we are asked to find the value of a, b, and c, given that the mean is 1 and capital F of 1 is 0.63. So we're looking at 3 unknowns here, so we will try and form 3 different equations. We will start with the obvious that the sum of the probabilities must be 1, which leads to 0.15 plus a plus b plus c plus 0.15 is equal to 1, and therefore we have that a plus b plus c is 0.7. We then have that capital F of 1 is 0.63. Now capital F of 1 is the probability of x less than or equal to 1. So if I'm less than or equal to 1, then 0.15 plus a plus b, that's 0.63. So 0.15 plus a plus b is 0.63. And we have that a plus b is 0.48. Now based on this, we can actually find the value of c, because we have that a plus b is 0.48. So I could say that 0.48 plus c is 0.7, and therefore c turns out to be 0.22. Now the third piece of information was that the mean value of x is 1, and we can find the mean by multiplying each x with its associated probability. So we've got that minus 2 times 0.15 plus minus 1 times a plus b plus 3c plus 4 times 0.15 is equal to 1, and therefore this gives me that minus a plus b plus 3c plus 0.3 is equal to 1. We also know that c is 0.22, so minus a plus b plus 3 times 0.22 plus 0.3 is 1, and therefore minus a plus b plus 0.96 is 1, and therefore minus a plus b is 0.04. So we end up with this equation here, that a plus b is 0.48, and this one here, that minus a plus b is 0.04. So I could add these two, which is giving me that 2b is 0.52, and therefore b is 0.26. And I can go back, maybe I can go to equation number 1, substitute b with 0.26, and I get that a plus 0.26 is equal to 0.48. So a is 0.22, and therefore we conclude that a is 0.22, b is 0.26, and c is 0.22. In question 2, we've got a group of 40 families, and we are being given information on whether they have a dog, a cat, or a rabbit as pets, and this is the given information. We've got D representing the families that have a dog, and C and R respectively for cats and rabbits, and we need to draw a Venn diagram to illustrate this information. Now notice that we are told that no family had a dog and a rabbit, which means that the D and the R sets do not overlap. So let's start by drawing the 3 circles, and we will start adding the information on our Venn diagram. So there it is, we've got 3 circles, it's D, C, and R. We are told that there are 2 families that had both a dog and a cat, so 2 will go in the intersection between D and C. We are told that 12 families had a dog, so 12 is the total for D, so that means that I've got 10 in the only D section. We had 9 families with none of these animals as pets, so 9 goes outside. And then I will put an X in the intersection between C and R, because we know that 11 families had a rabbit. So all of this is 11, which means that the only R region is 11 minus X. And then we had 14 families having a cat, so all of this is 14. we already have the 2 here in the x, so it means that the only C region is 12 minus x, and we know that the total here should be 40, so 10 plus 2 plus 12 minus x plus 11 minus x plus 9 is 40, which leads to 44 minus x is 40, and therefore x is 4. And I can now revisit to update my diagram. The 12 minus x is 8, the x is 4, and the 11 minus x is 7. So I have all the information on my Venn diagram. In B, we are asked to state, giving a reason, a pair of mutually exclusive events. So we have already seen that D and R do not overlap. Their intersection is empty, and this is exactly the definition of mutually exclusive events. It's events that cannot happen at the same time. So for part B, we can simply say that it's D and R because there is no family with a dog and a rabbit. In C, we are asked to find the probability that the family has exactly 2 of these kinds of animals as pets. So it's either those that have a dog and a cat, or those that have a cat and a rabbit. So 2 plus 4 over 40. That's the answer to part C. It's 2 plus 4 over 40, which simplifies to 3 over 20. In D, we need to show whether events D and C are independent. Well, 2 events are independent if the probability of both of them happening is simply the product of the individual probabilities. So we've got events D and C. I will start by stating that the probability of D is 12 out of 40, which simplifies to 3 out of 10. The probability of C is 14 out of 40, which simplifies to 7 over 20. And therefore the probability of D times the probability of C is simply 3 over 10 times 7 over 20, which gives an answer of 0.105. On the other hand, the probability of D intersection C is 2 out of 40, which is 0.05. So we can simply say that since the product is not equal to the intersection, then the 2 events are not independent. In part E, we are told that Sarah's family is in the group and her family has a pet cat. What's the probability that Sarah's family also has a pet rabbit? This is an example of conditional probability. So I will quickly redraw my Venn diagram to see exactly where the conditional statement that the family already has a pet cat will take me. This is my Venn diagram. We know for sure, it's a fact that the family has a pet cat, which means we are restricted in the C set here. So this family is one of the 14 families that have a cat. Now, what is the probability that they also have a pet rabbit? So it's the intersection with the rabbit. So it's 4 out of 14, which simplifies to 2 over 7. In part F, we need to find the exact value of the probability of D union R given C dash. This is yet an example of conditional probability. It is certain that we are outside of C, and the question is what's the probability we are also in D union R. So I will quickly redraw the Venn diagram and see where this will take me, taking into account that I'm outside of C. So knowing that we are outside of C means that we can be here or here or here, and we are wondering on what's the probability that we are in D union R, which means either D or R, and I'm taking the intersection with the things I already know for sure. So this means I want to be here or here. So it's gonna be 10 plus 7, that's 17, what I have ticked, over the total, which is 10 plus 7 plus 9, and this leads to 17 over 26. That's the probability of D union R given C dash. In question 3, we are being given information on the relationship between the number of washing machines sold M and the number of guarantee policies sold P. We've got a scatter plot here, and we're also being given some summary statistics we are asked in part A to show that SMP is 1373.6. Now we will start by quoting the formula for SMP, which is sigma MP minus sigma M sigma P over N. In our case, the sum of the product MP is 32,958. The sum of the M's is 1124, and the sum of the P's is 281. We've got a total of 10 observations. Plug everything on the calculator, 1373.6 as required. That's the answer to part A. In B, we need to find the value of the product moment correlation coefficient. So we know that the product moment correlation coefficient R is given by SMP over SMM SPP. We substitute the values, 1373.6 over the square root of 6046.4 times 382.9, and plug everything on the calculator, we get 0.903. Remember to give your answers to 3 significant figures. Now in part C, we need to state, giving a reason, whether or not the data is consistent with the manager's belief. Now there are 2 things we could say. One of them is based on the scatter plot. We see that the points lie close to a straight line, and therefore this is consistent with the manager's belief, which says that there is a relationship between the number of washing machines and the number of guarantee policies, and this can be modeled by a straight line. So we can see a straight line that can be fitted here. And another thing we could say is that since the product moment correlation coefficient we have calculated is close to 1, then this supports the manager's belief. In part D, we are being told that the manager noticed that the total number of washing machines sold was K times the total number of guarantee policies sold, and they are suggesting a model of the form P is 1 over Km, where K is an integer. We need to find the value of K. So to do that, I start by writing down the model proposed. P is 1 over K times M. If I sum both sides, the sum of the P's is 1 over K, the sum of the M's. Now, sum of the P's is 281, and sum of the M's is 1124. So if I cross multiply 281, K is 1124, which makes K to be 1124 over 281, which is equal to 4. For part E, we need to find the equation of the regression line of P on M, giving the constants A and B to 3 significant figures. So we will start by writing the equation. P is A plus BM. B is the gradient, is given by SMP over SMM. And this is 1373.6 over 6046.4, which gives an answer of 0.2272. Now for the intercept A, it's P bar minus BM bar, which is equal to 281 over 10 minus the value we just obtained for B of 0.2272 times M bar, which is 1124 over 10, and this gives an answer of 2.57, and therefore the equation of the regression line is P is 2.57 plus 0.227 M. In part F, we need to use this model to estimate the number of guarantee policies sold when 70 washing machines are sold in a month. So in other words, we need to use this formula here to predict P when M is 70. So we've got that when M is 70, we get that P is 2.57 plus 0.227 times 70. It gives an answer of 18.4677, so I would say 18 policies. But it's worth noting that the mark scheme is accepting anything between 18, and 18.6. In part G, we are told that the 70 washing machines are sold in January usually, and a bonus will be offered if we exceed the number of policies sold compared to what the model is predicting. We've got two models here. We've got the manager's model, P is 1/4M, and then it's Young's model, which is the linear model. And we need to decide, we need to recommend which model to use, giving our reasons. So let's start by writing out the two models to see exactly how to approach this part of the question. So the manager's model simply says that the number of policies sold is 1/4 M, and we know that when M is 70, then the model predicts 1/4 times 70, which is 17.5. So in other words, the manager model predicts 17.5 policies, and the linear regression model predicts 18 policies. So it makes sense to choose the model that predicts the less number of policies, because it's much easier for us to exceed this, and therefore we get a bonus. So we would recommend going with the manager's model. In question 4, we've got the birth weights of babies. They are given in a grouped frequency table. We've got the frequencies, we've got the midpoints for each class, and we are told that the histogram was drawn, and we are being given the dimensions of the box representing the 1.5 to 2.5, and we need to calculate the width and height of the bar representing the 3.5 to 4 class. So we'll actually start by drawing two bars, and we will indicate all the information there, hopefully getting the width and the height of this bar. So for the first bar, we know it goes from 1.50 to 2.50. It has a width of 1 centimeter and a height of 4 centimeters. So this means it has an area of 4 squared centimeters. And the frequency is 16 for this class. And we can see that in terms of the width, it covers a width of 1 kilogram, because we are measuring weights here. And we are interested in the 3.50 to 4.00 class. So we can see first of all that this is covering a width of 0.5 kilograms. And therefore we say that if 1 centimeter represents 1 kilogram, then obviously we need 0.5 centimeters for 0.5 kilograms in the horizontal. Now we know that the frequency here is 14, so we can say that if 4 square centimeters represents 16, then how many square centimeters will represent 14? So I'm using ratio here. 4 square centimeters represents 16, then x squared centimeters represent 14, and then x is simply 4 times 14 over 16, which gives an answer of 3.5. So we know that the area here should be 3.5 square centimeters, and therefore the height is simply that number that will give, together with 0.5, will give a product of 3.5. This should be 7 centimeters, and therefore we conclude that the width is simply 0.5 centimeters, whereas the height is 7 centimeters. In B, we are asked to use linear interpolation to estimate the lower quartile. We've got 98 babies in total. So to find Q1, we start by doing 98 over 4. This gives an answer of 24.5. So going back to my frequency table, it makes sense to add an extra column of cumulative frequencies here. So we've got 16, then it's 16 plus 24, which gives me 40. Then it's 40 plus 32, which goes to 72, plus 14 is 86, plus another 12, it's 98. We can see that the 24.5 observation is in this class here, This is where we will be applying linear interpolation to estimate the median. To draw a nice diagram here to help me set up my ratio to estimate the median. So there it is, somewhere between the 2.5 and the 3 we've got the lower quartile, and I put the observations on the top and the frequencies at the bottom. So we can say that the small gap over the small gap is equal to the big one over the big one. So we can say that Q1 minus 2.5 over 24.5 minus 16 is equal to 3 minus 2.5 over 40 minus 16. This leads to Q1 minus 2.5 over 8.5 is equal to 0.5 over 24. I can cross multiply and solve for Q1. I get Q1 minus 2.5 is 8.5 over 48, and therefore this leads to Q1 being 2.68 kilograms. In C, we are told that the median is 3.14 kilograms, the upper quartile is 3.55, and we need to describe the skewness based on the median and the quartiles. So to do that, I need to compare Q3 minus Q2 against Q2 minus Q1. So we have that Q3 minus Q2 is 3.55 minus 3.14, which turns out to be 0.41, and the Q2 minus Q1 is 3.14 minus the answer of 2.68 we obtained in B, which is 0.46. So we can say that Q2 minus Q1 is greater than Q3 minus Q2, and we know that when this is true, we conclude that the data is negatively skewed. So we have negative skew in this case. In D, we need to estimate the mean and the standard deviation. We are given some information here. So we know that the mean, W bar, is given by the sum of the weights over the sum of the frequencies. So W bar is sum of FW over sum of F. This is 311.5 over 98. Which gives an answer of 3.18 kilograms. Now for the standard deviation, I'm using the formula that says it's sum of FW squared over sum of F minus sum of FW over sum of F all squared and then square root. So I'm substituting all the given information. 1051.125 over 98 minus 311.5 over 98 squared and then square root. This will give me the standard deviation to be 0.789 kilograms. Quick reminder that the units of measure of the standard deviation are exactly the same as the units of measure of the variable itself, in this case kilograms. In E, we need to use the given formula to estimate the value for the skewness. We need to give answers to two significant figures. So we just apply the formula given here. We know that the skewness will simply be 3 times the mean, which was found to be 3.18 minus 3.14 is the median, over the standard deviation of 0.789, I get an answer of 0.147. I've been told to give my answer to two significant figures, so that's going to be 0.15. In F, we are now told that we split the 3 to 3.5 class into two classes, from 3 to 3.25 and from 3.25 to 3.50. And we need to state, giving a reason, the effect this will have on the median, and then the effect this will have on the mean. So first of all, we originally had 32 observations between 3 and 3.5, and we see that we've got 9 of them between 3 and 3.25 and 23 of them between 3.25 and 3.5. So we can see that the 49th value, which is exactly the middle value, will be the last observation here, because if we go back to the table, we had 16 people in the first class plus 24 is 40, and then this class here, the 3 to 3.25 has 9 persons, so it's a total of 49 up to here, which is exactly halfway through, because we knew the total is 98 babies here. So the median will increase since the 49th value will be at 3.25. And then for the mean, we can see that we've got more people in the higher end of this class, which means that the mean will increase. So let's explain this once more. The median will increase since the 49th value is at 3.25, and we were told that originally the median was at 3.14. And then the mean will increase since we've got more values in the higher end of the class, in the 3.25 to 3.50, rather than the 3 to the 3.25 group. So overall, this will contribute to the sum of the fx. This will increase, and therefore the mean will increase. In question 5, we've got the random variable x following a normal distribution with a mean of 10 and a standard deviation of 6. So we've got x following normal 10,6 squared, and we need to find the probability of x being less than 7. We will do that through standardization. So from x we go to z, and we deduct the mean and we divide by the standard deviation. So this is the probability of z being less than negative 0.5. Now, in order to use the normal tables, I need to express this as 1 minus the probability of z less than 0.5, which is 1 minus 0.6915, which leads to an answer of 0.3085. In part B, we need to find the value of k such that the probability of x being between 10 minus k and 10 plus k is 0.60. So it makes sense to draw a normal curve here just to put all the information on a graph. So we start with the bell-shaped curve. It is centered at 10, and we know that the probability of being between 10 minus k and 10 plus k is 0.60. So this is a symmetric interval around the mean, which means that the tails are 0.20 each. So all of these can be written as the probability of x being greater than 10 plus k to be equal to 0.2. I will standardize once more. So z greater than 10 plus k minus 10 over 6 is 0.2, which leads to the probability of z greater than k over 6 is 0.2. Now, since this is a small, nice probability, and this is a greater than, I go to the small table of normal probabilities, and I find that k over 6 is equal to 0.8416, and therefore if I multiply by 6, I get that k is 5.0496. For part C, we are told that we take a single observation of x and we draw a rectangle with vertices at 0, 0, x, 0, x minus 3, and 0, x minus 3. And we need to find the probability that the area of this rectangle is more than 40 square centimeters. Now this is worth 80 marks, so this means there's quite a lot of work involved here. So I will actually start by drawing the rectangle with these vertices just to see exactly what's happening. So there it is. It's easy to see that the area is given by x times x minus 3. Now, bearing in mind that x could take theoretically any value between minus infinity and infinity, this could turn out to be negative, or x minus 3 could turn out to be negative. So strictly speaking, we take the absolute value of the right hand side to be the area, because area is always something positive, and therefore this means we want the area to be greater than 40. which means that we need x times x minus 3 to be greater than 40. This is a quadratic inequality. So x squared minus 3x minus 40 is greater than 0. This factorizes into x minus 8 times x plus 5 greater than 0. The critical values are 8 and negative 5, which means that I could draw my parabola here. We see we've got the cuts at negative 5 and 8. We go plus, minus, plus. We want to be positive, so we either want to be less than negative 5 or greater than 8. And before I proceed on this part here, there's also the chance that x times x minus 3 is less than negative 40, which means that the left hand side will give me numerically a value that is less than negative 40, for example minus 45, and so the area in this case will simply be 45. So I also need to investigate this possibility. I expand the left hand side and collect everything on the left hand side. So x squared minus 3x plus 40 less than 0. I could actually complete the square here to see that x minus 3 over 2 squared minus 3 over 2 squared plus 40 is less than 0, which leads to x minus 3 over 2 squared plus 151 over 4 is less than 0. We know that there are no solutions here because something squared is always greater than or equal to 0, and I'm adding something positive, so there is no chance I get any solutions here. So no solutions on this part, which means that the only possibility for the area to exceed 40 is either x being less than negative 5 or x being greater than 8. So we will proceed then to say that the probability required is the probability that x is less than negative 5 plus the probability of x being greater than 8. I will standardize. It's the probability of z less than negative 5 minus 10 over 6 plus the probability of z greater than 8 minus 10 over 6. This leads to the probability of z being less than minus 2.5 plus the probability of z being greater than minus 0.33, and therefore this is 1 minus the probability of z less than 2.5 plus the probability of z less than 0.33, which leads to 1 minus 0.9938 plus 0.6293, with a final answer of 0.6355. In question 6, we've got 5 rounds of a tennis tournament, and after each round, winners go into the next round and losers are knocked out of the tournament altogether. So we have to pay £10 for an entry fee, and the person that wins all 5 rounds will receive a prize of $260. We've got Serena, who enters the tennis tournament, and this is the random variable representing the total number of wins. And we need to start by showing that k is 20 over 49. Now to do that, we know that the sum of the probabilities should be 1. So I could start by adding up. So I've got k plus k over 2 plus k over 3 plus k over 4 plus k over 5 plus k over 6 is equal to 1. This leads to 49k over 20 is equal to 1, and therefore k is 20 over 49 as required. Part B, for 3 marks, we need to find the expectation of S. We know that it's a standard approach to multiply the values of the random variable with the associated probabilities to find the expectation. So it's going to be 0 times k plus 1 times k over 2 plus 2 times k over 3 plus 3 times k over 4 plus 4 times k over 5 plus 5 times k over 6. This leads to 71k over 20 but we have just found that k is 20 over 49. So 71 over 20 times 20 over 49 gives an answer for the expectation of 71 over 49. In part C, we need to find the expected profit, and we know that she will be making a loss of $10 if she does not win the tournament, because that's the entry fee she had to pay to enter the tournament. But she will actually make a profit of 250, which is the 260, the prize minus 10, the fee to be paid, if she does go on to win the tournament. So we could draw up a simple table here. The profit can take two values only, minus 10, the loss of $10 or 250 if she wins the tournament. Now she will only be winning the tournament if she ends up winning all 5 rounds. So the probability of winning the tournament is k over 6. So I could fill in the probabilities here. So for winning the tournament and therefore making a profit of 250, it's k over 6. So the probability of making a loss of 10 is 1 minus k over 6. And therefore the expected profit will be minus 10 times 1 minus k over 6 plus 250 times k over 6, which gives minus 10 plus 130k over 3. I will substitute the value we found for k, so this is minus 10 plus 130 over 3 times 20 over 49, which turns out to be 1130 over 147, which is $769. We are then told that Roger also enters the tournament, and given that Roger is still in the tournament, the probability that he wins the next round is a constant p, and we've got the random variable r representing the total number of rounds that Roger wins, and we need to explain why the probability of r is 2 is p squared times 1 minus p. So if r represents the total number of rounds that Roger wins, it means that he stops when he has the first failure. So the probability that r is 2, we can say that this is simply the probability that he wins the first 2 rounds and loses the third. So the probability of Roger winning the first round is p. Given that they won the first round, they will win the second round with the probability of p again, and then they will lose the final round, so that's 1 minus p, which gives p squared times 1 minus p as required. For part E, we need to find in terms of p the probability distribution for r. So r, it's the total number of rounds that Roger wins, so he could be winning anything from 0 rounds up to all 5 rounds. I think it's a good rule of practice with these kind of questions to always consider the range of values that your random variable can take. In our case, it could be anything from 0, 1, 2, 3, 4, and 5. And the associated probabilities would be 1 minus p for 0, because that means that they lost the first round. For r being 1, it means they won the first and they lost the second. Then they won the first 2, lost the third, and moving on like this, we can fill in the table up to the final value for r, which is 5, which means that they won all 5 of them, and that's the end of the tournament. For part F, we need to find the smallest value of p so that Roger's expected profit is at least as great as Serena's. So I will draw up another table for Roger now for his profit. So he could make a profit of minus 10 or a profit of 250, and the associated probabilities will be p to the 5 for winning all 5 rounds and therefore making a profit of 250, and 1 minus p to the 5 for all other cases. Now the expected profit for Roger is minus 10 times 1 minus p to the 5 plus 250 times p to the 5, and we want this to be greater than or equal to 1130 over 147, which was the expected profit for Serena. Minus 10 plus 10p to the 5 plus 250p to the 5 is greater than or equal to 1130 over 147, which takes me to 260p to the 5 being greater than or equal to 2600 over 147. I will divide by 260 and I get that p to the 5 is greater than or equal to 10 over 147, and therefore p must be greater than or equal to the fifth root of 10 over 147, which gives a value of 0.584. So p should be at least 0.584. So smallest value for p is exactly this, 0.584.